Welcome to Homework Lib.
Hi, so over here we're given that phosphoryl chloride is used in the manufacture of flavor retardants. In this case, we're given the equation for the synthesis of this compound, and we're given the equilibrium constant Kc at 800, I think Kelvin probably, or 800 degrees Celsius. It really doesn't matter for the purpose of this question. And we're told that we're mixing 1.35 mole of PCl3 and 1.74 mole of NO2 in a 2.5 liter container. How many moles will there be of each gas when the reaction reaches equilibrium? So the first step that we need to do is to calculate the concentration of PCl3, which would be equal to 1.35 mole over 2.5 liters, which gives us 0.54 molar, and the initial concentration of NO2 that we're going to get, which would be 1.74 mole divided by the volume of the container, 2.5 liter. So 1.74 over 2.5 gives us 0.696. These are going to be our initial concentrations that we're going to add of the reagents. This would be all. In this case, I'm going to put everything in molarity units. The PCl3 concentration is 0.54. The NO2 concentration is 0.696. And of the products, we're going to have initially 0. The amount of change, we're going to have minus x, plus x, and plus x. So at equilibrium, we would get 0.54 minus x, 0.696 minus x, and x. Now, with this information, we can write down the value for Kc, which is going to be equal to the equilibrium concentrations of each of the compounds that we're going to get. In this case, the reaction is going to be completely balanced, so we don't need to worry about anything else, just plugging in the values. Replacing the equilibrium concentrations that we found from our ice table, we're going to find that this is going to be equal to x squared divided by 0.54 minus x times 0.696 minus x. And at the same time, this would be equal to Kc, which is 3.88. Thus, our equation can be rewritten as x squared would be equal to 0.54 minus x multiplied by 0.696 minus x multiplied all of this by 3.88, which yields 3.88 times x squared minus 4.79568 on x plus 1.45 826. Putting together all of the quantities, this would be equal to 2.88 x squared minus 4.79 568 on x plus 1.45 826 equal to 0. And we can solve this by either solving the quadratic expression in a scientific calculator or by finding the x12 values as the general formula, minus b plus minus the square root of b squared minus 4 times ac divided by 2 times a. So, solving this equation, we're going to find x1 and x2, which would be equal to 0.400316 and 1.26 485. So which the value is going to be correct? Let's look at the equations that we have. If we have a value larger than 0.54, we would get a negative number. So that means that we can disregard this value of x, and we're going to employ the value for 0.40. Thus, employing this value of x, the concentration of PCl3, which was equal to, looking back, 0.54 minus x, the concentration of NO2, which would be equal to 0.696 minus x, and the concentration of the products of POCl3 and of NO, which are going to be the same value for concentration, would be equal to x. So over here, we're going to round up our value as 0.40 directly in order to perform our calculations. So we're going to end up with 0.14 molar of PCl3, 0.286 molar of NO2, and 0.40 molar of the other two compounds. Now, these are the concentrations, so now we want to know how many moles will there be of each of the gas. So the amount of mole, remembering that molarity is equal to the amount of mole divided by the volume in liters, that means that the amount of mole would be equal to the volume in liters times the molarity, and the volume is equal to 2.5 liters. Thus, the amount of mole of PCl3 would be equal to 2.5 liters times 0.14 mole per liter, which gives us 0.35 mole. The amount of mole of NO2 would be equal to 2.5 liters multiplied by 0.296 mole, molarity, mole per liter, which is 0.74 mole. And finally, the amount of mole of NO, which will be equal to the amount of mole of POCl3, which is going to be equal to 2.5 liters multiplied by 0.40, which gives us 1 mole. And with that, it would be all. These are going to be the final amounts of mole required by the problem. Let me enclose it in red. Mole. And it would be all. Thank you very much and have a good one.